So I'm in R and I'm about to import the Steelers roster dataset. So I'm going to rename it as Steel. It's going to be easier to work on. So the roster appears up here. And one of the first commands I can do is called nrow. Steel. And that returns the number of rows in the distribution. So there are 93 rows, which is what we want. All right, so Stemplot, I want to look at that distribution, Steelers, and for example, we already looked at weight. Now, scale is equal to, so by default, if we do scale is equal to 2, then you've got twice as many stems as we've had before. So we can also do, for example, if I hit up, the up arrow, it brings back the last thing I had. I can also do scale is equal to 0.5. When I do that, it compresses things. So by default, it has a certain default setting. Scale is equal to 1. In this case, that was the one we saw in the lesson. And of course, the bigger the scale, the more it kind of expand things. So here's scale is equal to 4. And now I have 178, 179, 180. You can see how it is kind of expanding things. I can do scale is equal to 10. It just becomes kind of silly after that. But for different sets, it might make sense to do this. So let's look at another distribution. So stem. And let's look at the Steelers by age. So the distribution looks like that. So 22, interesting. Let's do scale is equal to 2. One second. Okay, this is what I want. So now I've got 22, 23, 24, 25, 26. You can clearly see the modal age. The most frequent one for players on the team is 24. There are, looks like 7 players that are 22 years old. One of the nice things about a stem plot is you've got, you clearly have the shape of the data, and you can, the whole data set is right there. So if I was to count every single one of those, I would end up with 93 different players. And one of the things we'll talk about later is this idea of outliers, data points that are very unusual compared to the rest of the distribution. So clearly you can see a lot of players in the vast majority of the players are in their 20s. And you've got a player who's 42 years old. So, and you can see a right skewed distribution kind of like bunched up on the left side, and you've got a tail going to the left. So same idea, I can do Stemplot. And let's do height. So steel height. Look at the distribution of heights, see if there's any sort of a pattern there. And let's do scale is equal to 2. Looks a little left skewed from this perspective. There's other tools we have in place that we can look at to see if it's indeed left skewed or right skewed. For example, if I do mean of the distribution and I look at height, and if I do the median of the distribution and I look at height, I can look at the relationship between the mean and the median. So here the mean is to the left of the median, which kind of further corroborates this idea that it might be a left skewed distribution. So the last thing I want to do is look at the table function. So with the table function, hopefully I'm in the right spot. So table, stealers, and now I can look at a categorical variable. So for example, position type shows me that there are 19 hybrid players, 26 linemen, and 48 skilled players. So when I'm analyzing categorical data, I'm going to be using the table a lot. So again, stealers. And for example, I can look at how many rookies we have. So if someone's a rookie, so 18 rookies and 75 non-rookies. So this will be an important function for us to know once we start analyzing categorical data and looking at probability and things like that. All right, so that's our introduction to Stemplots and a couple of basic R functions.